You'll want to pay close attention today because this lesson is going to teach you some things that you're going to need to know for months to come. So what we're learning about is angle pairs, pairs of angles. And so the biggest thing I want you to know is that we're always talking about two angles. And two angles can be adjacent to one another. They can be complementary or supplementary. Two angles could be called a linear pair, and two angles could be vertical angles. And maybe some of those you've heard of and some of them you haven't. So let's just go through each one. Let's start with adjacent angles. Adjacent is a fancy word for next to. And the technical definition says it's two angles that share a vertex in one side, but they don't share any interior points or they don't overlap. So let me show you an example. Here I've got an angle. Here's the vertex. I'm going to draw another angle that's going to share one of those sides. So I'm going to have this ray be the shared side. So I would just draw it maybe like this. And so I've got an angle 1 and an angle 2, and those would be adjacent angles. The two things you should check for is, do they both have the same vertex, and do they share a side? Those are also not overlapping. You can only be inside either angle 1 or angle 2. They don't share any common points. Next, we'll talk complementary and supplementary angles. And complementary angles, the definition is that it is two angles whose measures add up, the sum of the measures adds up to 90 degrees. Supplementary adds to 180 degrees. And I've learned some cool ways people have taught me these. The letter C can sort of turn into the number 90, and the letter S can sort of turn into the number 180. So maybe that's one way to remember the difference between the two. The way I have always done it is by alphabetical order. 90 comes before 180, C comes before S. So fun memory tools there. All right. You'll see in these diagrams we have a picture of two angles that would add up to 90 here that are adjacent to one another. They're sharing a vertex and they're sharing a side. They make a right angle altogether, but they wouldn't have to be adjacent to each other. They wouldn't even have to be close to each other as long as their measures add up to 90 degrees. Same thing on the supplementary angles. Here's what supplementary angles look like when they're adjacent. They've got that common vertex and a shared side. So you'll see that straight angle right there, right? Because they add up to 180. So angle 5 and 6 would be adjacent supplementary, but they wouldn't have to be adjacent in order to add up to 180. Let's do an example. Here we've got some pictures down here, a 32, a 122, and a 58 degree angle. Can you find a pair that would be complementary? Complementary would be two that add up to 90. Is 32 plus 58 equal to 90? I think so. So we will say that 32 degree angle, maybe I'll call it angle CAB. And the other one in the pair is the 58, angle RST. Again, I have the vertex letter in the center. Let's switch to supplementary. Do you see anything that adds up to 180? 122 plus 58, that is promise. Yeah, that's 180. So which angles? The 122 degree angle is angle, I could go CAD. And then our 58 degree angle again. And finally, adjacent angles, which angles share a vertex and a side. It would be these guys over here that are sharing vertex A and side ray AC. So that would be angle CAB from the bottom. Could call it BAC. And the 122, which I like to call CAD, but you could call it DAC. These two are probably new to you, linear pair and vertical angles. Here is a classic image of a linear pair. If you could just have that stuck in your mind, I think you'd be good. The technical definition for a linear pair is two adjacent angles whose non-common side are opposite rays. Do you see how those would be opposite rays? So that's the technical definition. I just want you to be able to identify a linear pair when you see one. So they have to be adjacent angles, and they basically have to have that straight line, which is why they're called a linear pair. Vertical angles are when you have a crisscross of two lines, and then you look at the ones that are across from each other. So angle 3 and angle 6 would be vertical angles. And they actually are congruent, since this will have such nice symmetry. So I put the swoop swoop on the 3 and the 6. Sometimes I wish vertical angles were called zertical angles, because there's always that X shape involved. Maybe that'll help you remember that those are called vertical angles. Angle 4 right here, a double swoop, since it's not the same as 3 and 6. And angle 5, angles 4 and 5 would also be vertical angles. And let's look at an example down here. Linear pairs. So we would have to find a straight line that's made up of two angles. The first one I'm seeing is maybe this line. Two angles that make up that line would be angle 1 and angle 4. So that would be one linear pair, angle 1 and angle 4. I can't use 2, 3, and 5, really, just because that's not a pair, that's a triple, that's a trio, so we wouldn't say that that's a linear pair. We could say angle 4 and angle 5, couldn't we? Because I'm seeing that straight angle right there. And then a common mistake that I've seen when people have answered this, a lot of people sometimes say angle 1 and angle 3, because technically angle 1 and angle 3 make that straight line. The problem there is that it skips over angle 2. And also, technically, in order to be a linear pair, you have to have a shared side. You have to be adjacent angles. So 1 and 3, not a linear pair. Let's go to vertical angles next. Remember, for vertical angles, I'm looking for an X shape. So I think I see one right here. So I could say that angle 1 and angle 5 are across from each other on that X shape. Angle 1 and angle 5. Now, if there was a nice way that I could name angle 2 and 3, then I could say that angle 2 and 3 go with angle 4. But again, that's just kind of awkward because I can't figure out a good way to name those without adding a bunch of points, but technically that could work. One of the common wrong answers that I get on this would be like angle 2 and angle 4. It's an awesome guess, but those are not vertical angles. Let's see if we can see why. Angle 2 is right here, and angle 4 is right here. I don't think that that's making a very good X. Makes more like a upside down peace sign or a chicken foot or something. So I wouldn't consider that an actual X shape. So that's the reason that 2 and 4 would not be considered vertical angles. Another answer I've gotten before is angle 2 and angle 5. So let's check out how that traces out. We've got angle 2 here and angle 5 here. And to me, that's looking like it makes sort of a K shape. Do you see that? So angle 2 and angle 5, not vertical angles. And now we're just going to practice to see if we can figure out each of these diagrams. It could be more than one, definitely could be more than one. Maybe you'd like to pause the video and think about this for a couple minutes, but I'm going to go through them with you. This first picture up here, I see a right angle. And so when I see a right angle, I know that's 90 degrees. So angle 1 and angle 2 will have to add up to 90. Those would be complementary. Are they adjacent? Do they share a vertex? Yes. And do they share a side? Yes. And so those would also be adjacent angles. The next example right here, we've got angle 1 and angle 2. That's a linear pair, isn't it? Remember, a linear pair is when we have two angles forming a straight line and they're sharing that side and vertex. They're adjacent angles that make a straight line altogether, a straight angle altogether. So that is a classic picture of a linear pair. And I don't know if you've thought of this yet, but if we added up the measure of those two angles, wouldn't it have to equal that straight angle? It would have to equal 180 degrees, which makes really all linear pairs are going to be supplementary. Fun fact. This next one, to me, looks like an X shape, doesn't it? So I have potential vertical angles. Are they in the right spot? Are they across from each other on the X? Absolutely they are. So that's some classic vertical angles. Maybe we should think about adjacent. Are those adjacent to each other? Do they share a vertex? Yes. Do they share a ray? Do they share a side? No, 2 has its own rays, and angle 1 has its own rays. So no, those would not be adjacent. Did we forget to check adjacent on this linear pair up here? We did. Those two angles share a vertex and they share a ray. So that would be an example of some adjacent angles too. Wow, jackpot. All right, this last one. Are they adjacent? Remember, adjacent means that they share a vertex. Oh, I think we lose already. Angle 1 has this vertex, angle 2 has that vertex. So they can't be adjacent because they don't share a vertex. Could they be a linear pair? And the answer is no again. A linear pair has to be adjacent angles. It's always going to look just like that picture. It's going to be just a single ray. So if I had another angle right here, I could say that angle 1 and 3 were a linear pair. But angle 1 and 2, not a linear pair. Not adjacent, not a linear pair. I don't see an X, so not vertical. Could they be complementary or supplementary? I guess I'd probably need more information, but it looks like maybe can you guys kind of see if I slid angle 2 into this little crevice? They're probably congruent there, aren't they? I would think so. So to me, those are looking like they could add up to a full 180. So I'm going to put a maybe possibly supplementary on that one. And so your goal after watching this video would be to be able to maybe draw a picture of each of these 5 types of angle pairs.